All right, so the wrapping on the outside of the kidney is called the fibrous capsule or the renal capsule. The renal cortex is the region of lighter material around the outside edge. The renal medulla is the darker material region, which is deeper inside the kidney. The renal pyramid is one of these fan-shaped or triangular structures. The renal column is an extension of the renal cortex that goes down between each of the renal pyramids. So if I ask you to name this structure, I'm looking for renal pyramid. Ask you to name this region, I'm looking for renal medulla. If I ask you to name this structure, renal column, if I ask you to name this region, it would be renal cortex. The renal papilla is the bump that protrudes into a tube coming off of the end of each of the renal pyramids. And then we have a blown up version of some renal cortex with one renal pyramid here in the center. So this bump on the end of it would be the renal papilla. Each renal papilla faces one tube, which is called a minor calyx. And then where two or more minor calyces come together, that tube is then called a major calyx. And then where all of the major calyces come together is called the renal pelvis, while it's still in the indented hilum of the organ. And then the ureter comes out of that indentation and goes down to the bladder. So for microanatomy, these little Christmas ornament balls are renal corpuscles. And then there's a blown up renal corpuscle over here. The glomerulus or glomerular capillaries are red. And then the visceral layer of the Bowman's capsule, the visceral layer of the glomerular capsule, or podocytes, are all represented by this tan material that's sitting right on the capillaries on this side of the model. The cells that line the outside of the globe of our Christmas ornament analogy are the parietal layer of the Bowman's capsule or the parietal layer of the glomerular capsule. And then where the podocytes come together and their finger-like extensions come together and make little slits in between the cells, represented by these red squiggly lines, are called filtration slits. So these red squiggly lines would be called filtration slits. Then we come out of the renal corpuscle into the proximal convoluted tubule, and these little bumps on the model are representing the microvilli that are on the cells here. Up here, this represents the distal convoluted tubule, and I don't see any microvilli. That's how I know that's distal convoluted tubule. Come back over here, this little section right here is what's blown up over here, so I can see the renal corpuscle, the proximal convoluted tubule, and then how the distal convoluted tubule can be right there, but it's distal in terms of how fluid would travel through the tube. So the proximal convoluted tubule is going to be the twisty-turny part of the renal tubule right after the renal corpuscle, so proximal to the renal corpuscle. Then it straightens out into this long U-turn shaped structure, which is all called the nephron loop or the loop of Henle. And the first part where fluid is going to travel downward is the descending limb. Then it goes over the U-turn or around the U-turn and then goes back up the ascending limb of the loop of the nephron. Then it gets twisty-turny again, and that is the distal convoluted tubule. And the distal convoluted tubule is going to connect into the collecting duct, and all these branches would go to individual nephrons. So for me, it's easier to remember that the distal convoluted tubule is closer to the collecting duct. The proximal convoluted tubule is closer to the renal corpuscle. Okay, then we move back to gross anatomy. On this model, which is a little twisted around, but we have the kidney here, and you can see a lot of the same structures that we went over, but no microanatomy. The adrenal gland is the gland that sits on top of the kidney, which you can also call the suprarenal gland. Then we have the ureters coming out of each kidney and going down to the urinary bladder. The urinary bladder opens up. This triangular structure on the inside of it is called the trigon. These two holes that have the same number and correspond with where the ureters come into the backside of the bladder are called the ureteral openings. And these ridges that make the inside of the bladder look like the skin on the outside of an orange are called rugae. The internal urethral sphincter is going to be the smooth muscle in the wall of the bladder, right where the urethra leaves. The urethra is going to go to the outside of the body. And then the external urethral sphincter is better viewed on the reproductive models. It's the urogenital diaphragm.